Welcome back, everybody. It's good to see you all back again. We're going to be going through another unit. We're going to be doing light vehicle cooling system safety, identify hazards and implement controls, which is part of our AUR TTC 001, inspect and service cooling systems. I'd also like to mention welcome to Malcolm Moraes, who's my Cert 4 training and assessor, third party observer for today. So welcome, Malcolm. And we've also got Jensen, Valen, Seth and Brian with us again. So that's great. If you guys just want to fill out the student attendance record sheet, that would be awesome. We pass that around. Whilst you're passing that around, I'll also mention about the occ health and safety issues and protocols and procedures for a training room. Sitting down on chairs could be uncomfortable after a while. You might cramp up. If you feel you need to get up, stand up, move around, by all means do that. If you have any questions, feel free to open up and ask. So we'll be going through some of this today. Anyone worked with cooling systems? No. So what does a cooling system do?
Cools the engine?
Keeps the engine cool, doesn't it? Keeps it at optimum operating temperature, actually. So your car will actually run better the hotter it is without overheating. It'll be more fuel efficient, will run better, and will last longer. I always say if cars are driven all the time and not turned off, they will last longer. The most amount of wear in an engine is on cold start. Everything's cold. A bit like me when I get up in the morning because I'm old. When I'm cold, I'm lucky I can move. I've got to warm up a little bit. Cars are the same, engines are the same. They've actually got to get up to operating temperature before they're actually warmed up, efficient, and doing everything properly. So the most amount of wear is caused when the engine is cold startup. So if we can have our engines up to operating temperature quickly, that's beneficial for us. So, as we're passing that around, any questions? No? So, does everyone know what parts are involved in cooling systems? Got a radiator at the front of the car. We have heater hoses. We have a water pump. The water pump pumps the water, all the liquid coolant throughout the engine, all around the cylinders, up through the cylinder head, and then back out to the radiator, where as it's coming down the radiator and air's coming across, it is being cooled down. So whilst the engine's cold, we have a thermostat. The thermostat remains shut when the engine's cold, so that no coolant can go back to the radiator. It circulates inside the engine, which gets it hotter quicker. Once it gets up to that operating temperature and the thermostat opens, it allows all that hot coolant back to the radiator to be cooled down as you're driving.
Yes.
Thank you, Brian. So, now that we are aware of that, anyone got any questions? No? Well, we're going to talk about safety. So, cooling systems do generate a fair bit of hazard. So what we've got is we've got liquid, hot liquid under pressure. That's our main one. The cooling system is always under pressure, pressurised, and that coolant is hot. When you have pressurised liquid, it actually can operate at a higher temperature without overheating. So we have coolant that's getting hot, It's building up pressure. Our main thing is we do not want to open that radiator cap when the engine's hot. When you look at the under the bottom of the car, you will actually see the radiator cap and it will have warnings on it saying, do not open when hot. And there's a reason for that. It's under pressure, and if you take that cap off, it'll blow up and you'll get covered in boiling, scalding hot coolant. So we'll move on to our next slide. So we're going to identify common hazards, recognise at least 5 key risks when working with cooling systems, understand potential consequences, learn what can happen when safety protocols aren't followed, and we're going to apply some control measures. So, common hazards. We've got liquid under pressure. That's our first one. So we can get scalded, burnt. That's our potential consequences. How can we control that? Wear PPE. Absolutely, that's our main thing. That's basically mandatory. But how else can we control hot liquid under pressure?
Let the car sit.
Let the car cool down. Thank you, Seth. That was great. We're going to let it cool down, aren't we? We're not just going to go off there and get a big block of wood and try and get the radiator cap off, or we're not going to get there with welding gloves and a welding helmet and try and take it off, because we're going to get burnt either way. We're going to let the car cool down, release the pressure, make sure everything's nice to touch, not touch it and you're getting your skin scalded off you. So we're going to let it cool down. That's the main thing. We've also got rotating parts. We have a fan behind the radiator. It could be electrical, it could be mechanical, but we have a big fan behind the radiator that's constantly drawing air through that radiator to keep it cool, especially when we're stopped at idle or if we're in traffic. Once we're moving, the airflow will come through the radiator whilst we're driving at speed. So there's no need for a fan. So the fan only works, its main function is when we're stopped in traffic to draw that air through the radiator to dissipate heat. Otherwise it'll just overheat. So they're the common hazards with cooling systems. We've also got pinch points. We've also got sharp edges. We've got chemicals. Coolant is a chemical. So where would we find information about hazards and controls with chemicals?
SDS.
SDS. Thank you, Brian. Safety data sheet. It'll give us all our control measures, what PPE to wear, where to dispose of coolant, which is the liquid hydrocarbon bin. Some places recycle coolant, would you believe? We can get coolant recycled back into coolant. So we have chemicals, we have rotating parts, we have liquid under pressure, we have pinch points. We've always got to make sure that we're aware of what's going on. So long hair, we need that tied up. We need no loose fitting clothing. We need proper PPE, including work clothes, steel cap boots, safety glasses. Otherwise, we could get injured, and we don't want that. So I've listed all the potential consequences: being burned, getting your hair caught. You could lose a finger with fans. Some fans are made out of plastic, some are made out of metal. The electronic ones, they might come on automatically. If you've got your hand somewhere and then all of a sudden that fan kicks in. So we also got to be aware of what may happen. We'll just move on to the next slide. Why cooling system safety matters. So we're operating under high pressure and temperature to regulate engine heat. So it's over 100 degrees Celsius, which means it has a higher boiling point than water. Water will boil at 100 degrees. Coolant can reach well over 100 degrees. And once it's pressurised, it can reach well over that again. Sudden release can cause severe scalding and burns. Cooling system injuries among the most common in an automotive workshop, because some people will take a hose off and without letting it cool down, and then all of a sudden it's all over them getting burnt. Chemical exposure and cause long-term health risks. As soon as you're lacking attention to what's going on, that's when things can turn pear-shaped. I've seen hoses explode. So the other issue we have is when we're pressure testing cooling systems with a pressure tester, because we want to check it for leaks, we've got to make sure that we don't over pressurise it. Cooling systems are regulated to a specific pressure, and that pressure is written on the radiator cap, and you don't exceed that. If you exceed that pressure, we have a risk of blowing the hose clamps off, blowing the radiator apart and causing severe injuries, and the car will overheat. So, common cooling system hazards. Hot coolant and steam, which we've talked about, can cause third-degree burns. Trip to the hospital, no one wants that. Skin grafts, we don't want that. Pressurised system, sudden releasing when opening the pressure cap or disconnecting hoses can just explode, spray water everywhere, coolant, hot coolant. Chemical exposure, ethylene glycol is what coolant is normally made from. We do have propylene glycol as well, but the most common one is ethylene glycol. Can cause skin irritation, toxic if you ingest it, respiratory issues to prolonged exposure. So we've got to make sure we're wearing gloves, wearing our PPE, reading the SDS to make sure we're aware of all the hazards involved. Slips, trips and falls, coolant spills on the floor, on the workshop floor, can be quite slippery. And walking in it, if you're walking in it, you're going to start spreading it all around. So we're going to make sure we're containing that in a drain tray of some description so that we can store it in the appropriate receptacle for waste disposal as per the regulations. So slips, trips and falls, we can get injured from falls and we don't want that. So we've got to make sure we contain that coolant in the drain tray. Moving components, cooling fans, belts and pulleys, which we've talked about, can cause serious issues. Belts and pulleys, you can get entangled up in them. We have seen that happen. Crushing or amputating injuries. If you get your finger caught in a fan or a fan belt going around a pulley, those pulleys, some of them made out of metal, your digits or fingers or something's going to get crushed, or you might end up with amputation. And no one wants to lose any limbs, fingers, because we need them. So you've got to make sure the car's properly isolated. So how do we stop someone from jumping in the car and starting that engine while we're trying to take the fan belt off?
Take the battery out.
Take the battery out. Very good, Brian. So we'll get the battery out of the car so no one can actually come along and hit the key and turn that key over and crank it over while we're trying to work on it. So we isolate and we can tag it out. Put a tag on vehicle being worked on, please do not start. Remove the key is another way, but battery is probably safest way, really, isn't it? Because we're actually removing all the power source to that vehicle, so no one can come along and start it up, or machinery, whatever you're working on. So we've got sharp edges, we've got radiator fins, brackets, damaged components. I know those radiator fins are very, very thin, very, very sharp, and can cut you when you least expect it. So you've got to be aware of where you're working. Some of those hoses, they get extremely tight and you've got to try and pry them off and you could slip. That's when you're going to cut yourself on something sharp. So you've got to make sure we're fully aware of what we're doing and what's around us. So gloves, and I'm not talking about nitrile gloves, you can wear those other gloves that will protect your hands a bit better. And I've also seen some of those thermal sleeves that people sometimes wear. So if you're working up in an engine bay and it's quite warm around the exhaust, but you're working on the cooling system trying to remove a hose, I have seen those thermal sleeves that guys wear that protects them from anything hot they may accidentally touch. Rightio, so moving along. Rightio, so addressing cooling system hazards, you can follow this in order of effectiveness. Can everyone see that? So elimination, hot cooling system, how do we do that? Let it cool down so it's safe to the touch. Substitution, use less hazard coolants where required. We can use non-toxic cleaning agents. We can use lots of different things. Engineering controls, spill containment. We can use drain trays. There's actually pumps you can get that actually pump the coolant out into a separate container, and they recycle that, and it actually pumps new coolant back in. So there is things like that we can do. Safety procedures, training, warning signs. So make sure we've filled out a take 5. Make sure we've identified all the hazards. Make sure we've got control measures in place. Make sure we isolate the vehicle so no one can actually start up. PPE, obviously. Heat-resistant gloves, goggles. You can wear an apron. Some people wear a leather apron to protect their clothes. So, control measures. Cool engine completely. Wait until the temperature gauge is right down, showing normal or cold, before you do any work. If it's really hot, just let it cool down. Go do something else for a while, for an hour or two. Okay, if you need to release that pressure, you can cover the cap with a thick cloth, towel, wet towel, cold wet towel, and you can turn it to the first stop position. They actually have a one stop and then a complete release. So that's like a safety stop. So you can actually just release it slowly to release any kind of pressure that's in the system. Obviously, letting it cool down would be the best option, but sometimes it can't be helped. So you've got to make sure you let that pressure dissipate before removing anything completely. Again, use proper PPE, heat-resistant gloves, chemical-resistant goggles, or a face shield. Refer to the SDS for different specific coolants, because like I say, we have different coolants, ethylene glycol, propylene glycol, we have wheat-based coolants, we have all sorts of different coolants. Some of them are toxic, some are less toxic than others. Contain and clean up spills, always use a drain tray. When connecting hoses, have your spill kit ready, or mop and bucket, and dispose of it in the correct manner. Isolate moving parts, disconnect battery, as our learned colleague Brian informed us earlier. Take the keys before working near fans or belts. Like I said earlier, many modern vehicles have electric fans that can operate unexpectedly. They can just come on, and you've got to make sure you have not got your hands in there. So battery disconnection would be the preferred choice. Safe radiator cap removal procedure. So, got to check that temp gauge, make sure it's in the cold position. Put all your protective gear on. You also might want to put guard covers on the car, fender covers, because we don't want to get coolant sprayed out everywhere. Cover the cap with a cloth like we mentioned earlier. Allow pressure release, and then complete the removal. Any questions? Rightio, chemical safety, coolant handling. Ethylene glycol, highly toxic if ingested. 30 ml can be fatal. Sweet taste attracts children and pets. If you've ever smelled leaking coolant, it does smell quite sweet. I don't know if you ever smelled it. It's actually sickly, but it does smell quite sweet. So can cause kidney damage and central nervous system depression. Skin absorption can occur over a prolonged contact. Vapours can cause respiratory issues. Safety controls. Always wear chemical resistant gloves, eye protection, work in a well ventilated area. Store it in its original container with the lid on tight. Got to make sure we do that, because sometimes people might store things in different containers, a Coke bottle or a drink bottle, and then someone come along and think they've got a bottle of Coke or a raspberry cordial and drink it. So make sure that it's in its original container, clearly labelled with the lid on tight. Clean spills immediately and dispose of used coolant according to our environmental regulations, which means we have to contain it and dispose of it in a liquid hydrocarbon bin. Wash your hands thoroughly after handling, even if you didn't wear gloves, and don't eat food without washing your hands, because that can transfer onto your food and you will ingest it. And always consult the SDS for specific handling with different types. Risk assessment. Replace an upper radiator hose. If you need to replace a radiator hose on a vehicle that was running 30 minutes ago, how are we going to identify the steps and do a risk assessment? What can we do? What's the hazard? Hot liquid. How are we going to control it?
Let the car cool.
Let the car cool down? Yep. What about rotating parts? How do we control that?
Isolate battery.
Isolate, remove the battery, remove the keys. Don't let anyone come anywhere near it while you're working on it. What if we've got to jack the car up? If we've got to get underneath it to do something under the car, what are we going to do there?
Make sure it's on the slocks, the hoist.
Hoist on the slots, proper lifting points. What about safe working load? SWL. What if our hoist doesn't have the ability to lift the vehicle? If the car weighs more than the hoist can lift?
Use jacks.
You can use a trolley jack, make sure it's of the correct SWL. Use jack stands. So we've got to make sure that we're assessing the risks. Rightio. Key takeaways. Always let it cool down first. Never rush cooling system work. It's a primary safety measure. PPE. That's our second primary safety measure. Stay vigilant. Make sure you take notice of what you're doing. Don't have your hands anywhere where a fan might turn on. Be aware. Use your own brains and safety. So the more you learn about the hazards and the controls and the risks, the more it'll just come second nature to you. Rightio, I think that brings us to the end of our PowerPoint presentation. So we have a little 5-question quiz here that we'll go through. Just pass one down the line there. Oh, sorry, mate. I nearly forgot you, Jensen. last time I stole Jensen's, but today I'll use my learned colleague Brian's. So, question 1. What is the safest way to open a radiator cap on a hot engine?
Wait for engine to cool down.
Wait for it to cool down, then release the pressure slowly. List 2 hazards associated with working on a cooling system.
Hot cooling.
Number 1, that's it, number 1, isn't it? Hot coolant under pressure. What else?
Moving parts.
Rotating parts.
Okay.
Why should coolant spills be cleaned up immediately?
To prevent slips.
Prevent slips and environmental harm. This next question looks like a bit of a trick question, doesn't it? Which PPE is most important when working with coolant? Circle all that apply. So, safety goggles. That would be one, wouldn't it? Gloves. That would be another, wouldn't it? Steel cap boots. Sure, catch a drop something on your foot. Apron. You could wear an apron, not necessary, really.
Optional.
Wearing steel cap boots, probably not really necessary, but we always make sure that we're dressed appropriately when we're working with any kind of mechanical part. And if we're in a workshop, we would be wearing all these items anyway. If we were working on something at home, then we might not necessarily be wearing all that, but we should, to protect ourselves, whether you're working at home or in the workshop. If you develop these safety protocols and stick to them continuously, then it comes automatic. True or false? The cooling system is never under pressure once the engine is off.
False.
That is false, isn't it? You know why it's false?
Still heat.
It's still heat, and it's actually getting hotter. Why is it getting hotter?
Is one from the engine still coming through?
Well, that coolant is still building up pressure. There is no fan drawing air over the radiator to dissipate the heat. So the cooling system will actually get hotter and build up more pressure after you turn the car off. But sometimes you might hear an electric fan still running after you've turned the car off. You might still hear the fan working. Some cars are designed to have the electric fan stay on to cool that car down, even though you've switched the car off. So that's why I'm reiterating about electric fans. Just make sure you're not anywhere near them, because they can come on automatically, and they can come on after you've turned the car off. So, battery disconnection, like my colleague Brian told me. Thank you, Brian. Rightio guys, as usual, we actually have a student survey form to fill out, which we'll get through in a minute. How are we going there, down the back?
Great.
Okay. Well, I'll give the guys a survey to fill out. We can just about wrap it up, I think.
All right.
Thank you.